Okay, welcome to today's tutorial. We're looking at the sine rule. Just a little bit of background. You should have already gone through, obviously, your right angle trigonometry with your SOHCAHTOA. This is where now we're stepping into our non-right angle trigonometry. So looking at what they call the sine rule. Now, hopefully you've looked at Sal's tutorial with actually the proof of where the sine rule comes from. What we'll actually be looking at is more how to apply the sine rule. Before we start, what I want to look at is just about labeling the triangle. Just like we did in the right angle trigonometry, it is very important about how we label our triangles. I'm going to start off with the triangle of ABC. Now, you know how we usually label the angles capitals, so capital A, capital B, capital C. It's important to note that if we want to talk about, say for example, this side, we can call it AC, but often we also call it little b because it's opposite its angle. Just like this angle here is A, so opposite that one would be little a, or side little a. Capital C, opposite that one would obviously then be little c. So often we relate to sides as little letters, A, B, little b, little c, and capitals as capital A, capital B, capital C. And it's really important to note, particularly with the sine rule, but also more important when we come into looking at the cosine rule as well, it's really important to know those relationships between the angles and their opposite sides. Okay, so we're going to look at exactly what the sine rule is. Okay, the sine rule. A over sine A equals B over sine B equals C over sine C. I'm just going to put a picture of that triangle back up again. Okay, so A, B, and C. Now just remember, we've just been through this, that I labelled the opposite sides. You can see they've got capital A, capital B, capital C. The little letters are opposite. So opposite capital A is little a, capital B will be little b, capital C is little c. Okay, so what does the sine rule actually mean? Well, the sine rule says if you know a side and its opposite angle, then the ratio of that side to its opposite angle is equal to another side and its ratio of the sine of its opposite angle. And that works out for all three sides. Often what you'll find, we'll only actually use two of these, okay, but it actually works for all of them. So again, I mean that comes from Sal's proof, but we know we've got the ratio of its side to the sine of its angle is equal to the ratio of the other side to its angle as well. And that's basically what sort of sine rule means. Something that I will mention out here at the moment, like with fractions, you can, because they're all equal, you can actually flip the whole lot. So if you wanted to, I mean, at the moment we've got the unknown sides, or the sides on top. I could actually rewrite this and have the sine A, so the sine angle on top, to equal the sine B, etc. Okay, that can work as long as they're all the same on the top. Okay, so all the sines are on top, or all the sides are on top. Okay, so how do we actually use this formula? I can see how it sort of works, but how it actually applies to a question. Okay, so let's have a look at an easier style of question to start with. So we've got a non-right angled triangle. Obviously if it was a right angled we'd be able to use our SOHCAHTOA, but we can't use that. So automatically the first rule I come to, if I can't use SOHCAHTOA, is I come to have a look at the sine rule. Now, what do I need in order to be able to use the sine rule? Well, I need to know my four pieces of information. So here I'm given 3. So I'm given the 10.4, the 5.8, the 68. I'm asked to find the fourth information is theta. So in order for the sine rule to work, I need to have the side and its opposite angles. Side and opposite angles. In this case, that all works out perfectly. So I'm able to use the sine rule. If that didn't happen, then we might have to be forced to use the next rule, which is the cosine rule, but obviously we haven't got up to that just yet. But obviously this works. So we spoke about being able to put either the sine angle on top or the side on top. So which should I do? When should I change it? Often when I look at it, I look at see where my unknown is. I like to have my unknown on top. Okay, and here the unknown is the angle. So I'm going to have the angles on top, just like I've written up there. So let's get to start off by putting sine theta over. Now remember, its opposite side is 5.8 equals sine 68 over its opposite side of 10.4. Now if you're doing general maths, it's nice and easy. Grab your graphics calculator out, put it into the equations mode. Obviously you put the theta as an x, so you can put sine x over 5.8 equals sine 68 over 10.4. Press your solve button and it'll come up with what theta is straight away. This is slightly more challenging if you don't have a graphics calculator. I need to get sine theta by itself, just like we would do, I guess, in right-angled trigonometry. How do we do this? Well, that comes back to our equations. How do I get rid of divide by 5.8? Well, we need to times it by 5.8. Okay, so that disappears. So I get sine 68 over 10.4 times it by 5.8. Now that gets me what sine theta is. We've got to be very careful here, because remembering back to our trigonometry, we need to find theta, not sine theta. So can you remember what we did when you had to find an angle? There was something we had to do, something in particular. Can you remember what that was? Hopefully, oops, I'll put tan there. Hopefully you remember that you need to put shift sine. Okay, because remember what we actually put in is sine to negative 1, and we type in our sine 68 over 10.4 times 5.8. Now often you can put that in first in the calculator, find the answer, and then press shift sin. Okay, and that will work out to be, I think it is 31 degrees to the nearest degree. Okay, might just want to check that. Obviously if you've got the graphics calculator though, you can see how much easier it is just by putting that bit into the graphics calculator and solving it straight away. It's nice and easy. Okay, so I mean that's looking at finding a relatively easy question, apart from, I guess, we got the sine theta, and you need to find actually what theta is going to be. Let's have an actual look at a HSC question. Let's see what this kind of looks like. A typical question. Okay, so again, what I'm going to write on here, I've got my sine A over A equals sine B over B. Okay, I don't need to write all three of them because I only have used two of them. Okay, so remember, if I'm using the sine rule, I mean it's not a right angle triangle, so we can't use SOHCAHTOA. Let's see if the sine rule works. We've got a side, we've got its opposite angle, that works. I'm looking for the distance of PQ. PQ is this one here, or it can also be called little r, I guess. So I look across here and go, hold on, there's a bit of a problem here. I don't have the angle. Now obviously we haven't done cosine rule, so it can't have anything to do with cosine rule. Before we go back to thinking about angle sum of a triangle, we should be able to work out, hold on, these three angles add up to 180 degrees. So actually, if I just add those two angles together and take them away from 180, I can actually figure out what that angle is going to be. If I do that, we should get 108 degrees. Okay, so that's a little bit more challenging because you've got to find that last piece of information. But again, I've now got my side and opposite angle, side and opposite angle. So it now is just a matter of putting that into this formula. Now, remember I said to you before that I look to see what the unknown is, and I like to have that on top first. In this case, the unknown is R or QP, whatever you want to call it, the side. So I'm going to put R on top over the sine of its angle, which is in this case is 108. And the only other bit of information I've got is this 76. Again, that's a side. I'll put that on top and put sine 26. So if you've got your graphics calculator, you can go ahead now and crack that out and try to work that out. If not, then obviously you've got to do that one extra step. In this case, it's probably a little bit easier than the last question because you're not finding an angle, so you don't have to press shift. It's just a matter of getting R by itself. So hopefully, if you've got a graphics calculator, you've already got the answer. If not, remember what's the opposite of divided by sin 108 or sine 108? It's times sine 108. It's gone off the screen there, I apologise there. Okay, but anyway, you can see I've got 76 divided by sine 26 times by sine 108. So if I crack that in, we should get 164.88, and that's kilometres, or we can round up to 165 kilometres. Okay, so again, if you had your graphics calculator, you would have got that answer a lot quicker by just putting that into your equations mode. Okay, so look, what we've looked at so far, if you recall, we looked at finding an angle, which is probably a bit more challenging if you're doing it the longer sort of method. Sorry, it wasn't that one, was it? It was this one up here. So again, finding the side and its opposite angle, side opposite angle, putting into a little formula, and then hopefully putting into a graphics calculator or solving it by hand. The same thing happens every time. I guess the biggest question that I get asked is, how do I know if I to use a sine rule? I think the easiest part to explain that is by simply saying that if it's not a right angled triangle, or if number one, if it's a right angled triangle. So if it's right angled, then we're using SOHCAHTOA. Number two, look to see if you have the opposite sides and angles. You have the side and opposite angles. Just like you can see here. Okay, so if I've got the side and one opposite angle, I've got another side, another opposite angle, then I'm able to use the sine rule. Okay, if that doesn't happen, then number three, it will have to be the cosine rule, which obviously that's something that we haven't looked at yet, but that's our next tutorial. Okay, go have a look through that sort of stuff. If you need any assistance, please drop me a line, and we'll see what we can do. Okay, hope this was of benefit to you.